Video 156 covered the knuckle joint on the geometric lock of the undercarriage. One area of the lock I could not mechanically see or understand, so I ran the model up several times. I'm a little bit clearer now, but I would like to see one on the bench. Problem: what stops the two halves of the struts going past 180 degrees? So I asked Phil.
So
I could see it going, I've had a look at it going up 2 or 3 times.
yeah, yes.
But the only way I can see the lock is on those two arms coming down.
Yeah, normally there's what's called a pawl, P-A-W-E-L, a locking pawl.
Yeah.
And obviously you've got the things hinging like this.
Yeah.
And to do that freely, but the geometric lock is normally a locking pawl that will ride up a cam like that, a detent, and then click in. Yeah, that's what normally happens. And then obviously when the aircraft lands, that makes sure the leg doesn't break. But in order to get your gear to go up, you have to remove that pawl. So that's normally that little jack will normally move the pawl out the way so that the knuckle can break again. Every single aircraft has got a geometric lock on the undercarriage. Yeah. But whether it's Russian, American, English, British, they all have a geometric lock. Yeah. But everybody does it their own way, even Supermarine to Hawker to Avro. There's no standard design, but there is always an over-centre geometric lock with a mechanical locking pawl that needs to be then removed for the hydraulic jack to break it.
I think I've now sussed it out and I can understand what actually happened. I have highlighted this. The main strut has an hinge in the centre. One half is connected to the wheel, the other side is fixed to the fuselage. Question: how does it stop travelling past the 180 degrees? This 90-degree angle casting with a large hole through it is fixed to the strut bearing the wheel. As it comes down, it is stopped travelling any further when it comes to rest on the face of the strut connected to the fuselage. This can be adjusted through 2 black adjustable links. The hydraulic locking system, I don't think I have a problem understanding after watching this numerous times.
The whole system is designed, and most aircraft have emergency undercarriage blowdown, so all the airliners, or like the Lightning, the Tornado, the Typhoon, every aircraft has got a backup to get the gear down. Lots of systems, like a B-17, if you've watched Memphis Belle, they have, they're the most unluckiest crew going on that final sortie. But they can't get the undercarriage down, so the handle that they pump. And I think that handle is probably, if the aircraft hydraulic pump is failed, that is a mechanical handle to pump fluid. Or, I'm not sure how the B-17 works, but I don't think there's going to be a mechanical jack. I think what you're doing is you're pumping oil, emergency undercarriage down.
I think I was talking to Gerb once, and he says if the hydraulics fail, they can use air pressure. There's a system where they can put it with air pressure to get it down.
So a lot of aircraft have what's called emergency undercarriage down. It's a blowdown system. That, like on the Lancaster, the brakes are pneumatic. They're not hydraulic.
No.
So at the time they used a lot of air to operate things. The brakes, the flaps. On the Spitfire, for example. So that air and the compressed air that's held can be then used to blow the undercarriage down in an emergency. But I'll defer to Gerbs on the Lancaster emergency down. If Gerbs says it's
I'll check up on that, but
ask him about it.
I then went to find Gerb to ask him about the pneumatic backup for lowering the undercarriage if the hydraulic systems failed. I couldn't manage to find Gerb, but Brad was at hand. He said yes, the backup was pneumatic. He then found a drawing, a diagram of the system. The drawing showed two air bottles on the inside of the front spar web, inside the fuselage. These air bottle holds 1200 psi and are primed before takeoff through the side of the fuselage. These are independent to the rest of the pneumatic system, the flaps and braking system. He later emailed me a photograph of just changed bottles, which are piped direct into the undercarriage ramp. The controls for this is situated on the engineer's panel on the starboard side inside the cockpit. The starboard side of the fuselage, under the wing and just above the bomb bay doors, are the priming points for the two air bottles.
This snake's the same as my old one.
Is much of it savable, or will you just use it for patterns?
Well, that looks good at the minute, but it all depends what it's like when we actually clean this corrosion off.
Yeah.
How bad that is, really.
Yeah.
I'm just looking at obvious stuff like this. It's different here, like this one here, which is quite a complicated one because it does a bit of an S-bend. It's got a slight corrosion problem to it.
Yeah.
Shame, because it's the only one that isn't straight, basically.
Yeah.
It's got that curve in it. I'll have to get that off, get that down to Simone and you can work on magic on it.
Yes. Yeah. Is it a box section or just a U?
It's a C section.
C section. Yeah.
With a slight lip on it. There's two types you find, one with a slight lip on it, you can get it in the same way, and one which is nearly a box section with a really curled over, with a bit more strength on it.
And how are you doing with that?
Another horrendous error.
Whereabout?
Annoying. This has had some rework on it at some stage, and they put this extra piece of skin on to make that flange. That flange has been either corroded away or damaged.
Yeah.
And they put this on, and they put these lovely rivets in there, but unfortunately,
Oh dear, yeah.
that rivet has gone through that bracket,
Yeah.
and it's not even.
Oh, it's a kind of a forged bracket or a cast bracket, isn't it?
It's a cast one, yeah.
Yeah.
Yeah. And so there's a pot rivet in there, which is all right, but that rivet there is
Too close.
actually overhanging the edge. Oh, that's horrendous. So whoever
Oh, it
did
is, yeah,
that,
you can feel it, can't you?
yeah. So whoever did that made this piece first, put all the holes in it, and then back drilled through that and put two holes in that.
Yeah.
That's what you find on old aeroplanes, I'm
Yes,
afraid.
yeah. So that's created quite a problem then if you can't get another bracket.
Well, that's okay for taxiing purposes.
Yeah.
But if it was for airworthy, that's it. That's a goner, that is.
Yeah.
But that's a horrendous things we're finding on this. Is what people have done.
Yeah.
The thing is, he knew it was there, and he still
Keep
put a
it in
rivet
the air in any way.
Yeah, whoever did it still put a rivet in it.
Yeah.
Rather than go, oh my word, we've done something wrong here, we'll have to change our bracket.
Yeah.
And it's been flying like that.
Right, thanks.
Just shiver down your spine.
Yeah, thanks, John. You crack it on, Keith.
This is just a jigging tool.
Oh, is it?
They're not going on.
No.
It's just so I can, when we get the stringers painted, I can fit the stringers and I'm not fighting the ribs all the time to get them in the right place.
The ribs are at an angle, should be upright when they get fitted properly.
No, they're all fitted at an angle. But the face, the face of the rib will be at 90 degrees to the edge of the rib, so it runs as a continual.
I'm not quite with you on that. These won't be upright, they'll be at an angle still, will they?
What's that?
These ribs.
Oh, the ribs, no, they're at an angle.
Yeah, they are at an angle.
Yeah, because when you look at the top of the wing, it slopes.
Oh yeah, that's right, and it's keeping these in line with the fuselage.
Fitted, they will be in line with these.
Yeah, I'm with you now, yeah.
Yeah? I thought you was talking about the stringers, sorry.
No. What goes here?
Engine.
Engine fits there, doesn't it? Oh.
Yeah, the engine goes.
Yeah. Right, just a quickie. How many tons of soda have you used then?
About 1.5 tons.
1.5 tons, that's good. And you recycle it, you sweep it up?
We've got we sweep it up every day. Effectively, if you use 3 bags of the stuff, you will get 3 bags of residue.
Oh dear.
Oh yeah, because it just shatters.
Yeah.
You know, you can feel the grittiness in it when you start. Once you've used it, it's like talcum powder.
So with it being finer, it can get less in a bag sort of thing?
Well, as I said, we normally reckon to pick up as much as we use.
Oh, that's good then.
So that then goes off to the recycling people and the way to go. I mean, you can dissolve it. But,
it's certainly doing a good job on these, isn't it?
Yes, it's without a doubt. I mean, if you look at all of these, that would have taken us an awful lot of time. I mean, the rib typically will take us about an hour on the soda blaster, and then to do one of the main wing ribs. And then you might be talking another hours to 2 hours, depending how bad it is, to remove the corrosion.
Yeah.
Because the soda blaster won't remove the corrosion; it'll only remove the oxide of corrosion. So, but yeah, I mean, it saved us a huge amount of time, and the chemicals obviously were pretty obnoxious. So we don't want to go down that road again.
No.
But we keep on saying, Keith is like the swan, you know, he's putting all these bits together and looking good. And John and I are paddling away like mad in the background. You know.
Are you losing weight through it?
I wish.
With the heat? Well, you're doing a great job. It all looks good now, doesn't it?
You know, you take